Welcome to readmeproject.com. Project title: Mode Switching for Energy Efficient Device-to-Device Communications in Cellular Networks. Now we are going to see the abstract of our project. To satisfy the explosive growth of high data rate local mobile traffic and provide better user experience, device-to-device communications have been considered as one of the key techniques in the third generation partnership project long-term evaluation advanced systems. With these D2D communications, through proximity, users can transmit signal directly without going through the base station. The system investigates energy-efficient device-to-device communications in cellular networks. We aim to maximize the overall energy efficiency of day-to-day users and regular cellular users while considering the circuit power consumption and the quality of service requirements for both type of users as well as power constraints. Three transmission modes, namely dedicated mode, reusing mode and cellular mode, are considered for the D2D users to share the spectrum with RCUS. Then interior point method is exploited to obtain the optimal solution. The simulation results shows that the system EE can be improved significantly with the proposed mode switching algorithm compared with the single mode transmission. Besides, it is also shown that the reusing mode is more preferred in the EE-based mode switching, while in dedicated mode in the spectrum efficiency-based mode switching in most situations. Now we are going to see the flow diagram of this project. First, the network formation is done. That is, the number of devices and the base stations are created in the network in the specific transmission area. The devices are considered as the nodes in our simulation work. So the nodes and the base stations are created in the network. Then the transmission mode is allocated. That is, the reuse mode, dedicated mode, and the cellular mode are considered here. After that, the devices generates data to transmission. If it's generate means the process checks the resource availability in the network. If the resource is available means then it performs the D2D communications with three types of modes. Else, it again checks if the resources are available not in the transmission modes. Finally, the performance is analyzed in which the existing system is compared with the proposed system with the help of its performance matrices. Let's see the output demo of our project. First, open the terminal window, then go to the directory where we have the code, then type ns space file name .tcl. If we give enter means now the nodes are created in the network and then the coding is running now. These are all the updated positions and the energy because our main concept is achieve energy efficiency. So for that each and every node's energy is updated in the network. This is the network animator window. Here only we see the simulation results. To run the simulation, click on the play button. So these two are the base stations that created in the network. And these are all the nodes, that is devices, which are going to communicate with the base station. This shows the simulation process speed. Now the node generates data and it accesses the nearby base stations with the cellular mode. So cellular mode means the node will, that is the device will communicate directly with the base station. Then the device to device also can be communicated with dedicated mode. Now the two devices are communicated with each other. So these communications indicates the uh, now again another user is communicated with the base station with the cellular mode. Here the interferences occur. So the modes are switching. Dynamically, the transmission modes are switching in the network. So this was our final result. So to see the performance results, back to the terminal window and then type GNU plot graph 1 dot plot. So this graph represents the cluster radius and its average energy efficiency. The existing have a high energy, but are proposed to have less average energy. So this shows that our proposed system performance is increased than the existing work. That's all. The demo is completed now. Thank you for watching this video.